Hi, this is Mrs. Nearing, and we're going to talk about how to determine the pH of salts. So the definition of a salt, it is the compound that is made during a acid-base neutralization reaction. And although we call those neutralization reactions, the salts that we make are not always going to be neutral. So the salts are ionic compounds, and so when you're trying to analyze a salt, you want to break it down and ask yourself, what's the cation and what's the anion? So first let's talk about the cation. You have two options from the cation. Remember, a salt is a product of an acid-base neutralization reaction. So the cation is either going to come from a strong base, and our strong bases are sodium hydroxide, potassium hydroxide, lithium hydroxide, so your alkaline metals, and then some of your heavier alkaline earth metals, calcium, strontium, barium. So if the cation came from a strong base, that cation will be neutral. It will not affect the pH of your solution. If the cation came from a weak base, so if it's the conjugate acid of a weak base, it itself will be a weak acid. Then you want to look at the anion. You've got two options for the anion. The anion either came from a strong acid, so you can think of it as a conjugate of a strong acid. Those strong acids, remember there's 7 that you should know. So hydrochloric acid, hydrobromic, hydroiodic, nitric acid. So any of those ions, nitrate, chloride, bromide, those would all be neutral. So the conjugate of a strong acid will be neutral. If the anion is the conjugate of a weak acid, it will be a weak base. So let's look at some examples of this. So sodium nitrate is our first example. Whenever I look at one of these ionic compounds, I'm going to break it down and say, what are my ions? So I've got the sodium ion, I've got the nitrate ion. The sodium ion, I'm going to look up here and say, well, does it come from a strong base or a weak base? And I'm going to know my list of strong bases and say, yep, sodium is the cation from a strong base. It comes from, I'll write down here, sodium hydroxide. Okay, that is like the origin of the sodium in my salt. So the cation from a strong base will be neutral. So that means our sodium ion will be neutral. It will not affect the pH. The nitrate ion, it's an anion. It could either be the conjugate of a strong acid or of a weak acid. And the way that you can look at it is to figure out what the conjugate acid is, you can just add an H to the formula. So instead of NO3, I have HNO3. And you'd say, hey, wait, HNO3, that is one of my strong acids. And if the anion is the conjugate of a strong acid, it will be neutral. So that means that the nitrate ion is also neutral. So I've got neutral, neutral. Overall, sodium nitrate should be neutral. So it should not affect the pH of my solution. Let's look at a second example. We've got sodium and we've got hypochlorites. Okay, sodium, we just addressed it up here, comes from the strong acid sodium hydroxide, so it itself will be neutral, because again, cation from a strong base will be neutral. My anion, it either came from a strong acid or a weak acid. So what you can do is, to figure out what the conjugate acid is, you can add a hydrogen to it, say, okay, HOCl, and then ask yourself, is that one of the 7 strong acids I have memorized? If it is not one of your 7 strong acids, then you should assume it is a weak acid, meaning that its conjugate is a weak base. So I've got a neutral cation and an anion, which is a base. So when I put this solution, this solid, into water and form a solution, it will make a weak base. The pH of the solution will go up. And the reason why, what is happening here, if you were to draw out the reaction, is that this hypochlorite anion is going to react with water and is going to take a hydrogen from water, forming HOCl and hydroxide. So this is what my anion is doing. This is why it is acting as a weak base. Remember, bases are hydrogen takers. Okay, over here, looking at this one, I've got sodium bicarbonate. Now, I guess we have a few examples with sodium here. So we already addressed that sodium is neutral. I'm just going to write that down. Sodium is neutral. And then we have HCO3 minus. It's an anion. If I want to figure out what its conjugate acid is, I'm just going to add a hydrogen to it and make it H2CO3. And then you ask yourself, is that one of the 7 strong acids I have memorized? If it is not, then it is a weak acid. So this right here is a weak acid, meaning that the HCO3 minus ion is a weak base. So this ion right here is the thing that's going to affect the pH of my solution. It is going to make this solution basic, so it will cause my pH to go up. And the reason why that happens is, let me erase this for a moment, is the bicarbonate anion is going to react with water. It is a base, so it's a hydrogen taker, so it's going to create H2CO3 and hydroxide ions. So this is what it makes it a basic solution, is that right there. All right, so the last one, ammonium chloride. So again, I want to look at my individual ions. I've got the ammonium ion, I've got the chloride ion. The cation is either going to be the cation from a strong base or the conjugate of a weak base. This isn't looking familiar as one of my strong base cations, so let's look at what the conjugate base would be of this. So to find the conjugate acid here, I added a hydrogen. So to find the conjugate base of this one, I'm going to remove a hydrogen. So the conjugate base of the ammonium ion is ammonia, NH3, and that's something we should recognize as being a weak base. If this is a weak base, then that makes NH4 plus a weak acid. So our cation is a weak acid. Now let's look at our anion. So our anion is the Cl minus ion, chloride ion. Its conjugate acid is HCl, hydrochloric acid. And I'm going to recognize that as being one of my 7 strong acids I have memorized. So if an anion is the conjugate of a strong acid, it will be neutral. So what that means is I've got the chloride ion's neutral and the ammonium ion is acting as a weak acid. So my solution will be acidic. Let me write that over here. This will be an acidic solution. And if I were to draw a reaction for what is happening, then I would write this. I would say, well, my ammonium ion is going to act as a hydrogen giver, and it is going to give a hydrogen to water, leaving behind ammonia. But this right here is what makes the solution acidic. So when I put this in water, it's generating hydronium ions, which will lower my pH. So that's how you determine the pH of salts. Look at the cation, look at the anion, ask yourself, does the cation come from a strong base or a weak base? Does the anion come from a strong acid or a weak acid?